Hello, my name is John Kelly and this is the Weber Auto YouTube channel. In this episode we will be covering the Honda 5-speed automatic transmission, the model AT5. The AT5 transmission has been around since about 2001 and has been used all the way up through just a couple years ago, and it has had several revisions done to it over the years, as many transmissions do. It is unique, and I'm shooting a video on it today because it pretty much is an automated manual transmission. This transmission, as you can see here to the side, we have traditional helical cut gears. We've got a main shaft, we've got a counter shaft, we have a secondary shaft. But what's unique about this transmission design, which is very impressive, is that instead of using the standard brass synchronizers with single, dual, or triple cone synchronizers to shift a manual transmission, they use pretty much an automatic transmission clutch pack, a multiple disc clutch pack, to replace the brass synchronizer, the synchronizer hub, the cone, the keys, the shift fork. All of that is eliminated and replaced with an automatic transmission clutch pack for each of the 5 gears. And so if we look right down here on the bench, I have an example of this clutch pack. Okay, if we look right down here, I have a gear and synchronizer assembly, or portion of a synchronizer, the synchronizer cone, out of a manual transmission. And right here I have a gear, and so here's the gear compared to this gear here. It's got finer teeth, but instead of having a brass synchronizer and a tapered cone to synchronize the speed and make the speed equal of these two pieces, we use a multiple disc clutch to do the synchronization. So in a manual transmission, back to this one, the gears themselves are connected to the engine through the clutch. Every time you let the clutch out, there's power to the gears, depending on which gear is selected. The synchronizer hub and the synchronizer are connected to the output shaft, which drives ultimately the wheels and tires. And so we need to synchronize the speed of those two so that the shift sleeve can come down and connect these little brass teeth with these iron teeth and basically connect the engine to the tires in whatever gear, for whatever gear ratio it may have. And so the larger the gear, the bigger, or the lower the gear ratio. And so when we compare this manual transmission gear to a Honda automatic transmission gear, we need to do the same thing. The gears themselves would be connected through the torque converter to the engine, to the crankshaft, and then there is a hub right here that would come in and sit over that, and this hub ultimately is connected through the final drive and to the tires. But in between the hub and the gear is a multi-plate clutch pack, just like any other automatic transmission would have. And so we have alternating steel, fiber, steel, fiber, steel, fiber, and so on plates. And so all of these plates will spline. So let me do an example here. We'll have a steel plate and then a fiber plate that would sit right there, and then another steel plate and another fiber plate. Notice that the steel plates have teeth on the outside of them which actually spline to this clutch housing, just like that. Notice the fiber plates have teeth that spline to the gear. And so as we alternate putting these together and By the way, this is a severely worn out third clutch pack on this Honda transmission. As those are splined on this housing here, on this gear, we come in with a hydraulic piston that's down in this bore here, and this piston has hydraulic fluid pressure that pushes it solid against this thick backing plate down here and squishes them all together, and this whole thing is rotating, and that will connect the engine to the output shaft through these clutch packs. And so every gear in this Honda automated transmission has a clutch pack similar to this. So let's take a look here. All right. Right here is the input shaft. And so our input shaft comes in from the torque converter that I have over there. We have power coming in. It comes just right up to the top of this shaft to this gear. Right here, this gear transfers power to this gear on what's called the counter shaft, this middle shaft right down the back. And then there's a secondary shaft right here. On this input shaft, the main shaft, we have fourth gear. This gear down underneath here is fourth gear, and we have fifth gear right here. And then this gear is just a transfer gear to connect to the counter shaft. Here on the top of the counter shaft, we have the third clutch for third gear, because that gear is on the counter shaft is not only a transfer of power gear, but that acts as our third gear for our third gear ratio. And it transfers power over here to our secondary shaft, where we have the second gear right here, along with two clutch packs to connect to first gear down underneath. And so think of every one of these thick pieces here as being another set of clutch discs that on a manual transmission would replace a gear and a synchronizer assembly. So of the clutches, that we have 5 clutches here. We have our first clutch that applies to give us first gear. We have a first hold clutch that is only applied in manual first, because as you are decelerating, there is a one-way clutch, a mechanical one-way clutch that's up inside of this housing. That mechanical clutch in drive range in first through fifth gear only holds it only holds in first gear while you're accelerating. When you decelerate, it does not hold, and there is no engine braking unless you take your gear selector, move it down into manual first gear, and then this first hold clutch comes on. Then we have a second clutch pack that is going to connect the gear, which is connected to the engine, to the main or the secondary shaft here. The secondary shaft down at the bottom has another gear that transfers back to our counter shaft right here that drives our final drive gear here with the differential on the other side of that. All right, so we've got first clutch, second clutch, third clutch, and then we have fourth clutch, fifth clutch, all replacing basically a synchronizer on a manual transmission. This, once again, these gears, it looks like a manual transmission, but it's automatically shifted with an automatic transmission hydraulic clutch pack rather than a synchronizer assembly. The clutch pack does the synchronizing, so it's an automatic synchronizer that can be precisely controlled. It can be quickly applied, so you have a fairly firm shift, or it can be slowly applied where you can have a real nice smooth shift. All right, let's look at some of the other pieces that are here on this transaxle before we do a demonstration of its operation. This transaxle, one thing I really like about Honda is that they have all of their solenoids on the outside of the transmission. I haven't seen anybody else do that, but I haven't seen every single type of transmission. I've seen a lot of them, but almost everybody else has their solenoids inside the transmission. You have to disassemble it, and they're on the valve body just to get to it. So we have a torque converter clutch solenoid to apply and release the torque converter clutch inside the torque converter. That improves fuel economy, and it reduces the heat generation that can occur when the clutch is not applied. We have 3 shift solenoids. We have a shift solenoid B right here, and then over here on the other side, on the side of the transaxle, we have shift solenoid A and shift solenoid C. So A and C over here. While we're here, let's continue rotating around. On the back of the transmission here, or on the bottom of the transmission, I should say, there is a filter that you would have to split the case and take it apart to change. But this filter, let's see, it says Filtech Incorporated on it. It has a Honda part number. That filter would be a filter that you would change only on an overhaul. That's not the filter that you would change if you changed the fluid. Instead, on the outer housing of the transmission, there is a filter, a screw-in filter that filters the fluid that comes back from the automatic transmission cooler up by the radiator or in the radiator. The fluid comes back from the cooler, goes in here, comes out the filter, and then goes and feeds the final drive unit, keep it lubricated with nice clean cool fluid through this little fitting right down here. So there's tubes and hoses connected to this transaxle. Now this transaxle is unique also because it has these little tubes all over the place inside of it. And so if let me zoom in a little bit here, and we'll take a look at some of these tubes. This tube right here connects the valve body. So we've got right down here, we've got the valve body. There's an oil pump in there. We have accumulators over here that cushion the apply of each clutch. There's a couple of more accumulators over here. There's another one in the accumulator, or in the valve body itself. We have a pressure regulator portion of the valve body. This little lever right here actually moves back and forth with the stator support assembly. And if you recall, a stator is what provides torque multiplication through your torque converter. Well, under those heavy load torque multiplication situations, this little lever here will actually push against this spring and increase fluid pressure to these clutches to give them more holding pressure so that they don't slip under heavy acceleration. But while we're over here on this side, notice also we have fluid that goes to the 4th clutch, which is here. We have fluid that goes to the 5th clutch, fluid for the 1st clutch. And this fluid, it's a unique system. It actually goes up into the top cover of the top housing of the transaxle here, and then over and down through the center of these shafts here. So if we want to apply the 5th or the 4th clutch, there's 2 different size tubes that go down this shaft, and that's the hydraulic passage to apply those. This counter shaft here has a single hole to apply the 3rd clutch. This secondary shaft over here has a single hole that applies fluid to the 1st clutch. But then the 2nd clutch and the 1st hold clutch are applied fluid from down below in this accumulator body. And then we have these short little tubes here. Let me zoom in and show you those tubes. Okay, so we have these 3 tubes right here. There's a feed tube and 2 return tubes, and those go to, if we look over here on this the outer case of the housing, the feed tube feeds these 2 solenoids here. So not only do we have 4 regular on-off solenoids just here on the the transaxle. These 4 solenoids right here, these are either on or off. They are not pulse width modulated. But over here on the rest of the transmission case, let me zoom in a little bit more. Right here we have what are called clutch pressure control solenoids, and there's 2 of them. This is clutch pressure control solenoid A, this is clutch pressure control solenoid B. The feed fluid from this center pipe comes in right here, and then the solenoids pulse width modulate that pressure to apply fluid to the clutch packs, to slowly apply them or rapidly apply them, depending on throttle angle and vehicle speed and several other factors that affect shift quality. All right, now these 2 other tubes here, these short little tubes, they feed another clutch pressure control solenoid on the side of the transaxle over here. So this is clutch pressure control solenoid C, and it just has a feed tube that feeds it, and then a return tube that if fluid comes through, it'll go through and go back into this tube here. Otherwise it'll dump out a vent and drop into the transmission. These 3 solenoids over here, these clutch pressure control solenoids, those are pulse width modulated to give us variable pressures for the apply and release of the 5 different clutches. Actually 6 if you count the first hold clutch. All right, other pieces that are here, Honda has, and I really like this, all kinds of pressure ports where you can hook up a pressure gauge. So most transmissions have at least 1 port where you can hook up and measure line pressure. Well, we've got 1, 2, 3, 4, 5, 6 places where you can hook up a gauge, and you can a pressure gauge for transmission fluid, and you can actually look at the pressure that is applied to each clutch, along with the torque converter passage and lubrication and so on. All right, let's scoot that back for a moment. Let's bring this other one in. So what we have here, in addition to these 3 clutch pressure control solenoids, we have an input speed sensor, the ISS. We have an output speed sensor, the OSS, right here. We have our cooler fitting, so the fluid leaves the transaxle on this port, goes out to the cooler, comes back in, goes through this filter that is changed at a periodic interval, and then goes into the final drive, as we've talked about. As we rotate around, we've got a dipstick tube right here, and then we have on the back of this trans, we have a 4th clutch pressure switch that detects when fluid pressure is applied to the 4th clutch, and a 3rd clutch pressure switch, which does the same thing. It detects when fluid pressure is applied to the 3rd clutch. We also have our park neutral position switch right here to detect what gear range we have selected, and that lets the computer know which gears you want to have. Since this is a computer controlled transmission, if you get any well, it controls how many gears you get. Do you get just 1st through 4th, or do you get 5th, or whatever, depending on where you've moved that gear selector. We also have right here on the bottom of the transmission a transmission fluid temperature sensor and a drain plug with a magnet on the other side. Now let me turn this around and let's look inside this transaxle housing. Here we go. Here's our transmission fluid temperature sensor right down here. So there's our fluid temperature sensor. And then you need to be aware when you try to disassemble one of these transaxles that there is a reverse idler gear in this transmission right here. And you cannot lift this housing off of the main base that I showed you with all the gears in it, unless you remove the pin that holds that idler gear in place. And so I want to show you how to do that. So this entire case assembly here normally would be sitting on top of this whole assembly. So it's just sitting here. Well, there's an upper portion that you have to undo first, and I've just got the bolts out of it for ease here. I'm going to lift that up and get it out. If we look at the bottom of this housing, you can see the two tubes here that feed fourth and fifth gears with these little tubes. This one over here would be our first gear feed, and this one would be our third gear feed. So those are the little tubes. Those big tall tubes that we saw on the transmission, they come up and connect through these two holes and through this hole, the three big tall tubes, to feed these three different tubes here. And they do it through this case, and I'll show you that here in just a moment. All right, so we'll set this out of the way. Oh, by the way, the input speed sensor, as you can see right here, is measuring the speed of that main shaft upper gear that's there. All right, on the back of this transaxle with the case cover removed, if you look right here, just inside of here is that reverse idler gear. So let me zoom in a little bit more and see if we can see that. Okay, so reverse idler. You can just barely see the gear teeth right there. There's a pin right here that to get this cover off of the top of that transmission case, the lower transmission case, you've got to take these bolts out. And you got to pull this pin out. So pull that pin out. And there's a couple of little washers and little bearings in there. This gear doesn't come out, but notice there's a slot here for it to slide over and out of the way. So we need that gear to move down to this position. Otherwise, it won't have clearance to clear the main shaft and the counter shaft of the transaxle itself. And you'll sit there trying to pry and pull and wonder, what am I doing wrong, trying to get this housing off. And so you've got to have that idler gear pin removed and slide that over. Now, another thing on disassembly, and that is when you get this upper cover removed, you are going to have 3 gears and the third clutch sticking out of the top here. So if we zoom in and take a look, so you're going to have this third clutch sticking out. You'll have these 3 gears sticking out, and you have to use special pullers to pull all of them off so that there's just the gear shaft sticking up out of the case itself right here. So it takes, well, these two here are, you can use sort of a strong power steering, or not power steering, steering wheel puller, just the 2-bolt style puller. This third clutch one, that one calls for a special tool to pull from the middle out to remove that, and I do not have that tool. I ended up using a large 2-jaw puller to remove it, but that isn't the proper way to do it. But I did it just for this demonstration, so I could get the whole thing apart. Obviously, it's not going to go back in an automobile. This is just a training transmission, but to get that third clutch pack off and have it reusable, you really should use the proper tool. All right, I'm going to set this housing off to the side now. I just want to talk quickly about how this thing is shifted and the function of these solenoids and switches and so on. So let me get these pieces out of the way. As I said before, these 4 solenoids here are on-off switches, or solenoids. They either allow fluid to go through them or they don't allow fluid to go through them. The clutch pressure control solenoids, the CPCs back here, these are pulse width modulated solenoids, and so they give us more than just on or off. They give us a variable pressure in between. So on and off would be a high pressure and a low pressure. This can give us anything between high and low pressure by bleeding off whatever's unwanted. All right, well, when we start driving down the road with this transmission, our input shaft is turning. So the input shaft is, Honda calls it the main shaft. That's this shaft right here. This is a bearing. There's bearings here that went into the back of this case and are held in with a snap ring. But this input shaft will turn. And I'm just going to grab a socket and a ratchet here. I'm going to show you. I'm just going to turn the main shaft from the opposite end. So this is just like if the torque converter was going to turn it. The main shaft turns the counter shaft turns the secondary shaft, and just everything is rotating. Notice I can hold the final drive from rotating because we're in neutral. There's no power being transferred through. So now let me go back to where we were. Okay, that's fairly close. So I've got an air hose here with compressed air. I'm going to use the air hose to apply these clutches and show you what's happening here. So remember, these 4 tubes, there's actually 2 in 1 right here. Let me zoom in so you can see that 2 in 1 tube better. You can see there's a small tube right there. I'm sorry, the large tube right there and the smaller one down the middle of it. Those 2 tubes feed the fourth clutch right here. So the 4th clutch and the 5th clutch. So the real skinny one feeds the 4th, the taller one feeds the 5th. Since I don't have a way to separate those 2 without that tube being in there, if I apply air to this main shaft right where those tubes go in, it will actually apply both of those. But I just want you to listen and let's hear what it sounds like when they apply. All right, now I'm going to zoom in so you can see the 5th clutch actually apply. Okay, so if you watch right here, you'll see a piece of metal rise up when we apply this clutch. See that rise up? That's because there's a piston in here that is pushing up on the clutch pack and applying the clutch, and it's doing the same thing on the 4th clutch at the same time, which would never happen in the car or should never happen in the car because of the tubes are split individually. All right, now if we go to the 3rd clutch, and there seems to have been some problem with this 3rd clutch, and this video is not to debate the issue of why there's been a problem with the third clutch. It's just that this is the third clutch pack here, and if I come in on the top and hit air to it, it applies and releases just like any other clutch pack. I know there have been updates to this transmission to make that clutch pack last longer. As a matter of fact, the clutch pack that I have right here on the table is a third clutch pack, and I just wanted to show you if you didn't see it before. Here's our backing plate that everything gets squished against, and then here is what's left of a fiber disc. Now you can see that there is some material. Let me zoom in a little closer here. You can see there's some material, some fiber material left on this disc. This side's even better. So that's sort of how a clutch disc should look. But as we start to work our way down through the steel, fiber, steel, notice this fiber clutch disc has no fiber material at all on it. So this disc, this shiny one with all the material worn off, used to look like this one, and it's just simply worn all the way off, and why is up to great debate, and there have been several revisions, as I've said, about this transaxle. And notice the rest of these are just down metal to metal. It's like having a set of worn out brake pads rubbing on the rotor. It's not going to be able to stop the disc, or it's not going to be able to hook all of those together and connect the engine to the wheels. And so what happens is this ends up slipping. And so as it slips, it generates a lot of heat, things turn black, the fluid turns black, and the engine will rev up, and the transmission will feel like it's slipping, because it is. On this particular third clutch that I took apart, and this was off of a 2003 model year transaxle, the hydraulic piston right here, let me zoom in just a little bit more. The hydraulic piston that sits in the bottom of this bore right here was kind of, it wasn't down flat all the way in the bore. It was up a little bit. It was tilted up. And there's a giant return spring, as you can see right here, that is supposed to hold that piston all the way down flat. And then there's a cap that goes on the return spring and a snap ring that goes on the return spring. Well, as you can see, this unsprung, it's tilted. And I believe even with it sprung, it was tilted too much, either from maybe a bad spring or assembled wrong, or just the force of this style of a return spring putting more force on one side of the piston than the other caused the piston to tilt just a little bit, which would cause a partial apply of these clutch discs, which would make them drag. And the ones at the very bottom, closest to the piston, are the ones that are all worn out. It's the ones clear here at the very top that had the least amount of wear. So I don't know. I don't work on Honda automatic transmissions very often, but that appeared to be a little odd to me when I was disassembling this. I'd never seen that happen before. But that's an old 2003 model, and I know that they've done many updates to this transaxle since then. Okay, well, let's take a look at just one application of a clutch on this transmission. And so what I'm going to do is I'm going to line up some marks here. Let's see, about right there. So if we look at our final drive here, I've got a yellow mark right here and a yellow mark right here. And if I put this thing in first gear by applying compressed air to the top of this secondary shaft, our first gear ratio should show up in how many turns did I have to turn the input shaft here to get one turn of the output shaft. And I did not look up the gear ratio for first gear on this transmission, but typically first gear ratios are somewhere in the 2.5 to 3 turns of the input shaft to 1 turn of the output shaft. And then there's a gear reduction in the final drive of another 3 or 4 to 1. And so I just wanted to show you that in first gear, which would be our lowest gear ratio, I'm going to hit the air to it and turn it. If we watch the yellow mark there, notice the final drive is not moving very quickly as I turn it. So that's first gear. Now, let me bring it back just a little bit. I'm going to apply third gear next. Third gear has a higher gear ratio, and so that should cause the final drive to turn a little faster as I turn the main shaft. So let's try that. Notice now it turns a lot faster, except when my shafts came out of alignment and the gears are binding up here on the final drive. But I think you've got the idea. Oh, I see what it is. Okay. If we on any of these clutch packs apply the air to it, then it replaces the synchronizer, and it allows us to just shift into whatever gear we want, or whatever gear is commanded by the ECM. And so let's get back to the solenoids just for a moment. These solenoids are on-off solenoids, which means they only have the fluid just go through them or not go through them. These solenoids, along with our clutch pressure control solenoids back here, these solenoids, the on-off solenoids, control the position of valves in the valve body. And then the clutch pressure control solenoids actually control the amount of fluid pressure to each of these 5 or 6 clutch packs. And so if we're in first gear over here, we apply that clutch and we're ready to go to second gear next. The proper combination of ons and offs to get us from first gear to second gear, the on-off solenoid will move a valve in the valve body to the second gear position, but that doesn't shift the transmission until the clutch pressure control solenoid sends fluid to the clutch. And then the clutch pressure control solenoid is variable, so that gives us the smooth shift or the hard shift or anything in between. And then once that shift is complete, then these on-off valves toggle again and apply full line pressure, which is the maximum pressure in this transmission, to the clutches to keep them held. So it's kind of a two-stage thing. Initially, the clutch is applied smoothly with the clutch pressure control solenoid through a valve in the valve body that the shift solenoid moved. But once it's finally applied, the shift solenoid moves the valve again and allows full pressure to hit the clutch pack to keep it applied. Now, if we just bypass these clutch pressure control solenoids and let full line pressure hit the clutch pack, every shift would be a hard shift. And so it's kind of a neat way of doing things, but it complicates the diagnostics a little bit because it's a two-stage upshifting and downshifting process. By the way, an interesting thing on this transmission, first gear stays applied in first, second, third, fourth, and fifth, along with that overrun or one-way roller clutch, or it's probably a sprag rather than a roller clutch, but it's a one-way clutch that's in there. It is overrunning in second, third, fourth, and fifth gears, because the inner shaft is turning faster than the outer shaft in the proper direction. All right, well, have I missed anything? Not that I can think of. So, an interesting transmission. I've been shooting videos on 5 different types of automatic transmissions for my students to look at. And we've looked at your regular planetary gear set style transmissions. And I see Honda and Acura now have a 9-speed transmission that's planetary gear set styled. Honda has a 6-speed version that's like this, except it has an additional gear, a 4th shaft. So this has a main shaft, a counter shaft, a secondary shaft. Their 6-speed has a 3rd shaft. It's called a 3rd shaft. It's really the 4th shaft, but you don't count that because the main shaft is 1. And then they have a couple of dual clutch transmissions, a 7-speed and an 8-speed. The 7-speed is a hybrid one with an electric motor, and then the 8-speed is a dual clutch transmission that uses a regular torque converter, but then it has the dual clutches are on the ends of these different shafts here. So the 5 different transmissions that I've been shooting videos on, and this is the last one, are a regular planetary gear set style transmission, which I've got several videos on those on the YouTube channel. I've got continuously variable transmissions, CVTs, that I've got a CVT video for a GM one and a Honda one. We have a electronic CVT, all the hybrid transaxles, which I've got 2 videos, the first generation or the 2nd generation Prius transaxle and the 3rd generation and above hybrid transaxle from Toyota. And then we've got the Ford style Getrag dual clutch transmission that I've got a video on also, that uses 2 clutch plates, but it's an automatically shifted manual transmission similar to this Honda one. It's automatically shifted, but actually with shift forks that are automatically shifted. And then we have this Honda style of an automated manual transmission where we use clutch discs to apply or to do the synchronizing of each of the gears. All right, well, that's just a short overview, quick overview of the Honda AT5. They also had an AT4, a 4-speed years ago. I don't know if they had an AT3. Maybe one of you do. I suspect they did back in the 70s when they first started selling vehicles here in the United States. But there's a 4-speed, a 5-speed, a 6-speed. They're all this same design or similar design. They've had some growing pains and some updates for these. But overall, a very cool design. Seemed to be a really heavy-duty, good, reliable transmission for the most part, although, like I said, there have been some problems. It's very picky about the fluid, is what I'm reading also. All right, well, that's it for the Honda AT5. Have a good day.